dioxide balloon experiment today. And as you saw there, you'll need a packet of Alka-Seltz tablets, a conical flask that measures 100 millilitres, and a balloon. And you'll need all these things to conduct the experiment, along with 50 mils of water per trial. So as you can see, I am filling up the conical flask now with 50 mils of water. And you don't want to put too much water in it unless you've got a very big conical flask, because you don't want it to bubble, overly bubble, so then it overflows. And not only will there be gas being released, but the liquid will spill over, making the experiment inaccurate. Per trial, you'll only need one Alka-Seltz tablet per 50 mils. If you're doing 100 mils, you need two, and so on. But we're only using 50 mils, so we are going to use one Alka-Seltz tablet. Alka-Seltz tablets come in little sachets, as you can see there. They're a big white tablet, which I'll show you in a second. Kind of like Panadol, maybe a bit bigger. That's what they look like there. Sometimes, because they're so big, they don't fit in the opening of the conical flask, so you might have to break it. As you saw there, as soon as it hit the water, it started to chemically react and bubble like that. And a chemical reaction is taking place between the Alka-Seltz tablet and the water. As you can see there, it's very murky and fizzy and white frothy, and that's all because it's reacting at the moment, and it's in the very, very early stages of reacting. As time passes, the water will get clearer as more gas escapes. So yeah, as you can see there, we know that, there it is a bit clearer, the water is getting a bit clearer. As we know, matter cannot be created or destroyed, it only can change form. And as the chemical reaction is occurring, it is changing into a gas as the solid and the liquid react with each other. The purpose of this experiment is to find out the weight difference before and after the experiment, to determine how much gas has left the conical flask. So before the experiment, you will need to weigh it with a set of electronic scales. You need to weigh the conical flask with the 50 mils of water inside, and the Alka-Seltz tablet out of the packaging, just to the side of it, not inside it, because it will start to react and it will be inaccurate. So you need to weigh them separately first, and then after the reaction is finished, which it's just about to finish now, as you can see, it's very clear, you weigh it again to find the difference in the gas. We're going to start trial 2, which is with the balloon. And the main difference here is to see if the balloon makes a difference with the amount of gas that leaves the conical flask. As you can see, I'm filling it with 50 mils of water again, and I am going to drop another Alka-Seltz tablet into the conical flask. Now with the balloon experiment, you have to be extremely quick, because as soon as it starts reacting, gas starts to leave the conical flask. So you'll need to have balloon at the ready. Sometimes it's really good to have 2 people doing this stage of the experiment, so you can have one person put the Alka-Seltz in and one person put the balloon on top. So as you can see it reacting there, I'm putting the balloon on top as quickly as possible. And as you can see now already, it is starting to expand. So to show you it from a wide view in a second. Depending on the balloon you have, obviously depends how big it will eventually blow. The balloon I have is pretty big, so it won't blow to a full circle, but you will see a change in the size of the balloon over time. As you can see now, it's already expanding. And that's because when the Alka-Seltz tablet and the water react and release carbon dioxide, it starts to blow the balloon as you and I would when we would be blowing a balloon when we release carbon dioxide when we breathe out. So basically, it's another way of blowing your balloon, which is pretty awesome. This is going to take a bit of time, but I'll just let you watch. As you can see now, it's much bigger than a deflated balloon. And if you squeeze a balloon, as I'm doing now, you can see there is air inside because it has a little spring when you put pressure to the balloon. And now it's actually able to stand upright because of the amount of gas. In the conical flask, the tablet is still reacting, so the chemical reaction is still going on, so it hasn't stopped. It's still filling up the balloon with air, just at a less rapid rate. Well, that's pretty much the end of our experiment. Thank you for watching.